My name is Colin Walls, and today I'm going to continue with my series of video blogs looking at USB. I'm particularly interested in looking at USB from a software engineering perspective, but we need to look at hardware as well from time to time. In today's session, I want to look at the communications on USB. This requires a number of concepts to be explained, as well as the basic mechanics. First of all, let's take a look at the USB controller. This diagram, we can see that there is the USB interface on the left, which connects up to the host or the hub. And on the right hand side, we have the CPU of the device that we are building. The connection between the USB interface electronics and the CPU of our system are a series of buffers called endpoints. Now, endpoints are, as I said, basically a buffer. They're a termination connector, and the device can have up to 16 endpoints. Each endpoint can have up to 2 addresses, one for in and one for out, that's upstream and downstream, and therefore there can be a total of 32 possible addresses. Every device must have an endpoint 0, both in and out, even if it doesn't have any more endpoints. So endpoints are a physical phenomenon as well as a logical structure. Most of the rest of USB is defined basically by software and protocols. So again, we need to understand some more concepts. Now, USB is a master-slave protocol, and it uses a concept called a pipe. Now, a pipe is a connection between the endpoints on either end of the USB bus. So a logical connection between the endpoints. The pipe also defines the transfer type. The other concept that we need to take a look at is transfers, USB transfers. Data is moved by means of a transfer, and this consists of one or more transactions. And those in turn are comprised of packets. Packets may be tokens, data, or handshake. A transfer may be mixed with other data on the bus, but a transaction is an unbroken stream of data on the bus. Now, there are 4 types of data transfer: control, bulk, interrupt, and isochronous. And we need to look at each of those individually. Now, first of all, we have control transfers. Now, control transfers are used for identification of a device and its initial configuration. All devices will support them, and they can be used at all speeds. They're message-based protocol transfers, and they use endpoint 0. And there is error correction included to ensure accuracy. The second kind of transfer is called bulk. Now, bulk transfers are used for high data volume devices, things like hard drives and so forth. These are devices where speed is very nice, but not absolutely critical, but accuracy is important. So they cannot be used at low speed, that wouldn't really make any sense, but data is streamed, which means that there is no overhead of message addressing. There is error correction to ensure accuracy. Now, another kind of transfer is called interrupt. This is used for low volume devices, and it's rather confusing because there's no interruption going on. The device, the peripheral is interrupted rather than the CPU. We don't use interrupts in that context in USB. Interrupt transfers can be used at all speeds, data is streamed as well, and again, error correction is there for accuracy. And the last class of transfer is isochronous. This is used for very high volume devices, like streaming audio and video, where delivery time is more important than absolute precision. It can't be used at low speed, again, that doesn't make any sense, and data is streamed to avoid the overheads. There is no error correction because the error correction is rather unnecessary because speed is the priority. When you're watching a video, the odd few pixels dropping out are not even noticeable. So that's an idea of some of the data transfer, some of the communications aspects of USB. Next time, I'm going to look in more detail at the software aspects of USB, look at the layers involved and how they all come together to make USB work. So until then, bye for now.